Good morning. This is your math sensei, Mr. Spensei, and this is quadratic factoring when a does not equal 1. But we're going to begin with factoring when a equals 1, and we're going to label a parabola, make sure we have the parts knocked out. So first off, we have this parabola here, and we're going to start with the labeling first. And this right here is a root, also known as a zero, and it occurs at 9 comma 0, where this is my x and this is my y. I also have another root or 0 at 1 comma 0, and again this is my x and this is my y. So that's these points right here. Next, we'll look at our next thing we're going to label is our line of symmetry. And the line of symmetry will always be, for our class, x equals. So for algebra 1, we're only going to be dealing with functions. And when we're dealing with a function, the line of symmetry will be x equal. What is x equal? Well, x equals, doesn't matter where I put my pin on that line, and remember the line of symmetry cuts the parabola in half, is going to be x equals 5. The very last thing we're going to label, which may have been, should have been the first, I don't know, is the vertex. This point right here where it changes directions is the vertex. And in our case, it occurs at 5 and negative 16, where this is my x and this is my y. And the vertex will either be at a point like this, in which case it's a minimum, or at a point like this, in which case it's a maximum. In our case, it's like this one. So this is a minimum. I'm going to transfer this information over here. So we have 5, negative 16, and we said it was a minimum. Our line of symmetry was x equals 5. And the roots are at 0, 1, or excuse me, 1, 0, because this is my x, this is my y, and then at 9, 0, where this is my x and this is my y. We're going to skip this and we'll come back to it in just a moment. Our domain. As long as we're dealing with a quadratic that's a function, it'll always be the same. So for algebra 1, all real numbers. And remember, the domain is the x values. The range, on the other hand, is the y values, and you have to be careful with this because you're going to start at the lowest point. Well, the lowest point on this thing is at negative 16. So we're going to have the range is negative 16 is less than or equal to y, is less than, and we have arrows. It's real important to notice we have these arrows because these arrows tell me it's going to infinity. So we have less than infinity. And it's actually going to positive infinity, but we never write this part. We only write this part, but really we need to flip it so that y is greater than or equal to negative 16, or y is greater than or equal to all real numbers greater than negative 16, because that's probably the way it's going to be show up on the STAR exam. Okay, we're asked to factor this. Well, a in this case is 1, b is negative 10, and c is 9. So let's go back to that C. I told you we were going to come back to it in a moment, and we're coming back to it now. We said we're going to do the y-intercept. The y-intercept is C every single time. So if this continued up, it would cross the axis, or intercept the y-axis at 0, 9, where this is my x and this is my y. So C will always be your y-intercept. Okay, important to know that. So we need to factor this. Well, we're going to need the factors of 9. And the factors of 9 are, and just as a reminder, you can go to y equals and put 9 divided by xton, blue graph, and we get 9 and 1. And remember, we always want the large factor on the left, L for left. And we have 3 and 3. Those are the only factors we have. Now, I have to look at my middle term. And because my middle term is negative, I know this is negative. To figure out the other term, I need to draw the triangle. And I have a negative and a positive, and what's left over is a negative. So I needed to add up to negative 10. These do. So my factored form of that parabola is x minus 9 times x minus 1. And I want to show you something real quickly. Y equals clear. If I put in the original equation, x squared minus 9x plus 9, and I graph it, that's what we get. On the other hand, if I come back and I put in the factored form, and I'll put that directly below it, parenthesis parenthesis x minus 9, close parenthesis, and then x minus 1, and I graph that. Let's go back to y equal, I had a typo there. That should have been a 10x plus 9. Okay, let's graph them now. There's the first one, and the second one is exactly the same. It lays directly on top of it. Okay, so it's super important to know that these are different ways of expressing the same thing. One other thing I want to point out to you, as those are my factors, but notice my roots are the same factors, they're only switched. This was a positive 9, that's a negative 9. So when they're inside, they're liars. When they're out like this, they're telling the truth. So you're going to continue on with factoring, but now we're going to move to when A isn't 1, and this is a special case when everything is divisible by 2. So first off, in this case, A is 2, B is negative 30, C is 28. Now, as it turns out, I can divide every single one of those numbers by 2. So let's do that. If I do that, I have 2 parentheses y squared, and once again, this is a special case, plus 14. So at this point, I'm going to need the factors of 14. Well, the factors of 14 are going to be 14 and 1, and then 7 and 2. And we have a negative and a positive, so we draw the, first off, this is a negative term. So that means my large factor has to be negative. But I have a negative and a positive, so what's left over is a negative. So the two factors I need are 14 and 1. So this is going to be 2. Don't want to forget about that 2. We need to bring it straight down. And then we're going to have y minus 14 and y minus 1. And that will be our work for that one. Here, it's divisible by 3. So even though we currently have 3, negative 24, and 45, we can divide all of these by 3. And when we do that, we're going to have 3 parentheses. This will be a 1 out here. 24 divided by 3 is 8. 45 divided by 3 is, this should be a W. I'm going to rewrite all that. 3 parentheses W squared minus 8W plus 15. So I'm going to need the factors of 15. And the factors are 15 and 1 and 5 and 3. Now, I look at my middle factor and it's negative. So that means my large factor is negative. I go to the triangle. And once again, I have a negative and a positive. So this means this is a negative. And I need the two factors that sum up to the middle term. So my answer is 3w squared, 3 parentheses w minus 5 times w minus 3. Because now these two sum up to 8, and this will be my final factored form just like that. Okay, that's special cases when we can factor. What we're mainly going to run into are problems like these next four. In the next four problems, we have 5 squared minus 8y plus 9. So we have 5, negative 18, and 9. Unfortunately, we can't factor this because this is not a 1. We need to convert this to a 1. To convert this to a 1, I'm going to need to take this number and multiply across. When I do that, I'm going to get y squared minus 18y plus 5 times 9 is 45. I'm going to put this 5 off to the side because we can't forget about it. We started off with a 5. We're going to need to come back to that. So I'm going to need the factors of 45. Well, the factors of 45 are 45 and 1. And by the way, if you're struggling, you can go to y equals, I'm going to clear this stuff out. And we have 45 divided by the xton, blue graph, and we're going to get 45 and 1. We'll also get 15 and 3, and we'll get 9 and 5. And at that point, we repeat. Well, when I look at my middle term is negative. So that means my large factor is negative. I go to the triangle, and I have a negative and a positive. So this means these are also negative. So I need to get to negative 18, which is this right here. So I have y minus 15 parentheses y minus 3. So far we're doing the same thing except for this part where we multiplied at the beginning. But I told you we couldn't forget about that 5. So now I need that 5. And that 5 I'm going to bring over and divide everything by 5. Well, this divides nicely, so this is just y minus 3. This doesn't. If it doesn't divide, we slide it over to the front and we just go 5y minus 3. And that's and that right there are our factored form. So this gives us our factored form. It asks us to find, set each factor to 0 and solve for x. So when I do that, I'm just going to cut this in half. I'm going to go, well, y minus 3 equals 0. I'll add 3 to both sides. So I have y equals 3. On this one, I'm going to have the same thing. I'm going to have 5y minus 3 equal to 0. I'm going to add 3 to both sides. And now I have 5y equals 3. Divide both sides by 5. And I get y equals 3 over 5. So it crosses the axis at 3 and 3/5. Okay? So these are my roots. So this is a root, and this is a root. So in this case, we're starting off with a equals 2, b is 11, and c is 5. 2 won't go into all of these, so we're going to have to multiply the first number times the last number. So this is going to be, and I want to write that 2 out here because I don't want to forget about it. So we have this 2, and then we have x squared plus 11x plus 10. All I did was take the first number times the last one. So I need the factors of 10. Well, the factors of 10 are 10 and 1 and 5 and 2. Both of these are positive. So both of these will be positive. I need the factors that go to 11. Well, 10 and 1 do that. So now I have x plus 10 times x plus 1. But I can't forget about that 2. So when I come over here, I'm going to have to divide by 2, both of these. So this divides evenly, so this becomes x plus 5. This does not divide evenly, so I have to drag it to the front, and it becomes 2x plus 1. Okay, so this right here is my factors. This is my, these are my factors. I'm done with my factors, but I need to find my roots. To find my roots, I'm going to take both of those and set them equal to 0. So I have x plus 5 equals 0 and 2x plus 1 equal to 0. I'm going to subtract 5 from both sides, and I get x equals 5, or x equals negative 5, and that's my root. Over here, I'm going to subtract from 1. This will go away, and I have 2x equals negative 1. Divide by 2, x equals negative 1/2, and this is my root. Now, you should be able to tell that, hey, 10 over 2 is 5, and all we did was switch the signs. We had 1/2, we switched the signs. So not very difficult to make the transformation. Okay, in this case, A is 4, B is negative 15, and C is negative 25. I can't divide all of these by 4, so I'm going to have to multiply. When I multiply, this gives me 100. So I'm going to write this 4 out here because I don't want to forget about it. And so now I have w squared minus 15w minus 100. Large factor, small factor. And I'm going to need the factors of 100 because this is always going to be A. So I have 101. I have 25 and 4. I have 20 and 5. And I have 10 and 10. Well, I look and the middle factor is negative, so my large factor has to be negative. Okay, continuing on, I go, well, I need to make my triangle to find out what my small factor is. So I have a plus and a minus and a minus. What do I have? A minus minus? So that means these have to be a plus. Well, which ones give me 15? These two combine together, because if I take the calculator and I go negative 20 plus 5, and I get negative 15. So in this case, I have w minus 20 parenthesis times w plus 5. But I can't forget about that 4 that I had outside that we multiplied by the beginning, so I have to put it over here. And this ends up being reduces to w minus 5. That's very nice. This does not reduce, so it slides to the front and becomes 4w plus 5. So this is my factored solution. I set them both equal to 0, so I have w minus 5 equals 0, and I have 4w plus 5 equals 0. Add 5 to both sides, and I end up with w equals 5. Here, I subtract 5 from both sides, and now I have 4w equals negative 5, divide by 4, and I end up with w equals negative 5/4. So both of these make up my roots. Okay, last one. 6y squared plus 5y minus 6. So we have, and by the way, 6 doesn't go into all of them. 6 won't go into 5 evenly. So this is 6, this is 5, and this is negative 6. Large factor, small factor. Since it doesn't divide evenly, we're going to have to multiply the first number times the last number. Don't want to forget about that 6, so I'm going to write it off to the side. Here's the 6 we can't forget about that was multiplied. And then we'll come back and use it in a moment. We have y squared plus 5y minus 36. So I need the factors of 36. And there happens to be a lot of them. There's 36 and 1. There's 18 and 2. There's 12 and 3. There's 9 and 4. And there's 6 and 6. I notice that the large factor, or that the middle factor, is positive, which means my large factor has to be positive. I go and make my triangle, and we have a positive and a negative, which leaves a negative left over. And I need to get to 5. Well, these two, a 9 minus 4 will get me to 5. So I have y plus 9 times y minus 4. Now, we multiplied by 6, so we can't forget about it. So I have to divide by 6 here. Well, 6 won't go into this evenly, but guess what? Something crazy happens on this one. So we kind of have an extra step. We have 9 divided by 6, math, enter, enter, and it reduces to 3/2. So this becomes y plus 3 over 2. You always need to check to see if it reduces. This one also reduces. Always check. 4 divided by 6, math, enter, enter. And this reduces to 2/3. So this is y minus 2/3. Now you can do that on Desmos. At this point, we want to move this to the front and this to the front. So this becomes 2y plus 3, and we drag this to the front, and we get 3y minus 2. Need to set both of these equal to 0. And I'm going to subtract 3 from both sides. I get 2y equals negative 3, divide by 2, and I have y equals negative 3/2. On this side, I add 2 to both sides, and I have 3y equals 2, divide both sides by 3, and I end up with y equals 2/3, and these are my roots. All right, I hope this helps. Look forward to seeing you on the next one. Thanks for watching.